We continue to solve the problem of the Kuwait flow for the flow that is taking place between two infinite plates with the described or prescribed conditions. We were to obtain three unknown constants C1, C2, C3. We have obtained the value of C3, which is C3 is equal to P naught, and we write down the equation. Then you will also note that this condition, it represents a simple hydrostatic pressure distribution, which is P minus P naught equal to minus rho Gz. This is what we have obtained, and you will see that this is a simple hydrostatic pressure distribution. The normal pressure that occurs or that takes place when there is a hydrostatic condition of a fluid. So although the fluid is maybe moving, but the pressure in this problem is not playing any contribution, at least for this situation. And therefore, we make this statement that for incompressible flow fields without free surface, there is no free surface. Remember, the flow is taking place between two infinite plates. So the fluid is bounded by these two plates, and the hydrostatic pressure does not contribute to the dynamics of the flow field. Now that is the important part. Now it may change under certain other conditions, but as far as the present conditions are concerned, the assumptions that we have made for this type of Kuwait flow, when there is no external pressure being applied, the pressure is not playing much role here. Now we try to solve the constants C1 and C2. This is a picture trying to describe the same thing, that the only contribution being made by the pressure is the hydrostatic pressure that is changing with respect to height, and it has a large value when the height is the maximum, and it has a minimum value when the height is a minimum. Then, of course, the directions are taken in such a way that the horizontal direction, the gravity is acting downwards, that is perpendicular to the plane of both x and y. But remember, it's very important to note that this flow is only taking place for such conditions where the fluid does not have a free surface. It is bounded by two solid boundaries. We try to determine the C1 and C2 that occurs in our earlier equations, and we need to determine that. When we substitute the value that U is equal to C1, then the value of the C2 is equal to 0, and the value of C1, it turns out to be V over H for the boundary conditions that we have. And the boundary condition is that when y is equal to 0, u is 0. There is no movement there, but when y is equal to h, then u is equal to v. So these are the two conditions, and when we substitute that, so here in this part, we substitute y equal to 0, we obtain C2 equal to 0, and again we write down that y is equal to h, then u is equal to v. That is the value of. So from this equation we obtain C1 is equal to v over h, as you can see very clearly, and thus we have determined all the unknown constants that were occurring in this problem, C1, C2 and C3. So this is again the picture of the fluid flow. which is taking place such that no velocity at the bottom. This plate, when y equal to 0, is fixed, and when the distance y is equal to, let us say, h, then the velocity, the x component is v, capital V, and for that the fluid can be described, the fluid flow can be described by the result that we have obtained, u is equal to v into y over h, where capital V is a constant velocity with which the fluid is moving. And so what is the relation? What is the implication? The implication is it can be interpreted both from this equation or even from the geometrical picture that is drawn here, that u is linearly proportional to y. When y is 0, the velocity is 0. And when y is increasing and it takes the value h, that is the maximum value that it achieves. But during these changes, during this movement, it is changing linearly. As h increases, the velocity, of course, the value of this one is. And here, of course, the velocity at x equal to 0 is minimum, that is described by the equation. So u is proportional to y is what the answer tells us, and that is what so this is one of the exact solution of Navier-Stokes equation, but you can see that it is under very restricted conditions, and many assumptions were made